Hi everyone, go ahead and check your answers to the day one homework. If you have any questions, I can help you with them when I return. So feel free to pause and take as much time as you need. You also need to make sure that you have a compass and straight edge for the start of this lesson. So grab those if you don't have them already. All right, so today we are going to talk about the distance from a point to a line and also the perpendicular bisector theorem. So even though we're never going to use a ruler to measure distance, for now, I want you to take a ruler and measure the distance from C to AB. And at first, you might wonder, like, well, where am I going to measure from? Am I going to measure from, see my cursor on C, to AB right here? No, that wouldn't make a lot of sense, right? In our minds, we automatically assume that a distance is going to be the closest. And that distance that's the closest is actually going to be the perpendicular line from C to AB. So every time we talk about distance in this class, we are defining distance to be the length of the segment that has its endpoints on the point and the line. So that line will be perpendicular. So now what we're going to have you do is we're going to have you construct a perpendicular bisector on the segment below. So go ahead and pause the video to do that. If you forgot how to construct a perpendicular bisector, you're going to put your compass on one endpoint and open it up more than halfway. Swing a semicircle. Put the tip, the pointy part, on the other side. Swing a semicircle. And then where they connect, that will be your perpendicular bisector. So now the question is, after you do that, if you were to pick a point on this perpendicular bisector, so it looks like I picked this point right here. What do we know about the distance from this point to the ends of the segment I just bisected? And hopefully you notice that they are the same distance apart. What if I picked a different point, like this point down here? You can visually see or test it with your compass that this distance to this distance is the same. This is the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if this is true, it's on the perpendicular bisector, then this is true, that this length and this length are congruent. The converse is also true. The converse, remember, is when you go in the other direction. If you have a point that is equidistant from the endpoints of a segment, then it must be located on the perpendicular bisector. So if you're given this, then you know that this blue line has to be the perpendicular bisector. So that's the converse. So now we're going to go through a couple problems about the perpendicular bisector theorem. So 3A says, from the information given in the figure, how is MT related to AH? So hopefully you noticed that MT is the perpendicular bisector of AH. So notice I abbreviate perpendicular with this upside down T, and bisector I can abbreviate with BIS. So if I know I have the perpendicular bisector, MT right here, then I know a lot of things. I know that this point right here, since these are both 15, that's the perpendicular bisector, and this point has to be perpendicular, excuse me, has to be equidistant from the two endpoints. Now for D, it says how far is M from AH? How far is M from AH? So remember, I'm not talking about this distance. It has to be the perpendicular distance. So that means I have to find this leg right here of this right triangle. And hopefully in your brain you're thinking, wait, right triangle? I have two sides for a right triangle? Hopefully you're thinking Pythagorean theorem. So I just blew up the picture a little bit here. Here's the distance we're trying to find. So we're looking for the leg. I have the other leg, and then I have the hypotenuse. So a squared plus b squared equals c squared, x squared plus 9 squared equals 15 squared, x squared plus 81 equals 225. I subtract the 81. Take the square root of 144. Technically it's plus or minus 12, but I'm talking about a distance, a length, so AH must be 12. All right, 4. Why don't you take a second and read what 4 is asking. Segment CD is the perpendicular bisector of AB. So it's doing two things. It's perpendicular, it's making those right angles, and it bisects, which forms the midpoint of AB. And we want to find X. So if you want more time to think, hit pause. If not, and you're ready, since CD is the perpendicular bisector, point C is on the perpendicular bisector, so it is equidistant from endpoints A and B. So that means I can set the two lengths equal to each other and solve. So I'm solving the equation to get X is 6. If the question asked me to justify with our geometry reason, it would be because of the perpendicular bisector theorem. All right, 5. DE is the perpendicular bisector of segment RA. If RE, find RE if RE is 5x squared plus 2x minus 15, and EA is 3x squared plus 12x plus 33. So go ahead and work on it. And when you're ready, I'll show you my work. So we're using the perpendicular bisector theorem. So since we know that E is on the perpendicular bisector, that E is equidistant from R and A, therefore I'm going to set 5x squared plus 2x minus 15 equal to 3x squared plus 12x plus 33. I see the x squared, which makes me think I'm going to have to factor. So I get everything to one side. Hopefully you noticed that there was a greatest common factor of 2, so I can divide out the 2. And now I'm able to factor using IM. So what multiplies the negative 24, but adds up to negative 5. So I've got negative 8 and positive 3. So then when I set them equal to 0, I get 8 and negative 3. Remember, you have to test both of them. So I'm going to come over here. I'm going to plug in 8 for x, and I'm going to plug in negative 3. When you do that, both answers work. So RE can either be 24 or 321. So don't forget to check both answers and sub them in. All right, 6. BA is the perpendicular bisector of ER. Find BR and EA. So go ahead and fill in 19 minus 3y. And if you'd like a moment to try this on your own, go for it. All right, since BA, see how I highlighted it, is my perpendicular bisector of ER, that means ER is the one that's being bisected, and we have our right angles. So B is on the perpendicular bisector, which means that BE is going to be congruent to BR, and A is going to be congruent, EA is congruent to RA. So because B and A are on that perpendicular bisector, they're equidistant to those two endpoints. So our setup over here is 19 minus 3y equals 5x. Notice I have two variables. So in your head, you should be thinking two variables means two equations. So I got my one equation, and then I wrote my second equation. 2y equals 12 minus 3x. So from there, I have to solve the system. So notice I did some work under here to get everything to one side. I got my negative 5x, my negative 3y here equals negative 19. And I have 3x plus 2y equals 12. I decided to multiply through to eliminate my y's. So I multiplied this equation by 2 and this one by 3. So here are my new equations right here. When I add them together, my y's are eliminated. I have negative 1x equals negative 2, so x is 2. Once I found x to be 2, I decided to use this equation, which came from right here. I subbed in x is 2, and then I was able to solve for y. My justification for this is that I'm using the perpendicular bisector theorem. They wanted me to find BR and EA. So BR is right here, and EA is right here. So then I came back and I subbed in y is 3 and got 10, and I subbed in x is 2 and I got 6. If you feel good about the lesson, you may start the homework right now. Hopefully you did some pausing so that you're able to think about the concepts of the perpendicular bisector theorem. If you need to go back and watch it again or slow it down, feel free to do so. And then when I'm back, I will help you with any questions you have. Hope you have a great day. Take care, everyone. Bye.